Hello students. Today's lesson will be on approximation. It's a simple way of finding an integral without actually taking the integral.
So, is this like using Euler's method in a way?
Kind of. Except instead of calculating slopes, you're finding the area of rectangles and then adding them together over a particular interval.
Oh.
Here, if you wanted to approximate the function y equals x squared using the left-hand approximation method, we would begin at our original point, point 0, and draw a rectangle with our step size of 1. We would then go from 1 up to the graph and over our step size to 2, and so forth and so on. Now that we have our 5 rectangles, we add the areas of these rectangles together to approximate the integral. So here we have 0. This one would obviously be 1. This one would obviously be 4. This one would be 9. And this one would be 16. Adding these numbers up, we then have approximated an integral. So 0 plus 1 plus 4 plus 9 plus 16 equals 5 plus 9 plus 16. And we get 30, which is the area underneath the integral. In this example, we'll be doing the same integral, except instead of using the left-hand approximation, we'll use the right-hand approximation. To do the right-hand approximation, you begin on the opposite side of the interval, namely at 5. So just like over there where we made the rectangles, we'll make rectangles here also, except we'll start here and complete it by going 1, which is our step size over, and drawing the rectangle. And we repeat this process until we have drawn rectangles over the entire interval. By adding these rectangles up, we can approximate the area of this interval. And as you see here in the calculations, this comes out to be 55. Now if you look at the graph, this area is larger than the actual area underneath this graph of y equals x squared. This is because this graph is increasing and concave up. So what are our approximations? The midpoint approximation. It's much better than the right-hand or left-hand approximation in approximating these intervals. We begin by finding a point in the middle of our step size, which is 1. So if we begin at 0, our point would be right here in the middle at 0.5. We then draw a rectangle all the way over to 1, just like we did before. We then go to 1.5, and this would be our new rectangle. And we continue this process just like we did before, and then add the rectangles to get our final area. By adding these rectangles up, we have a much better approximation of the actual interval. So as you can see here, after you find the area of all these rectangles and add them up, you get your final answer of 165 over 4. In this approximation, the trapezoidal approximation, we begin at our beginning point like always, and instead of making rectangles, we make trapezoids. We do this by drawing a line from our origin point to a point of our step size. So as you can see here, we draw a diagonal line to where 1 and the graph of y equals x squared intersect. We continue to do this for the rest of our step sizes, making 5 different trapezoids. And then, by adding the area of these trapezoids, we get a much better approximation of the value of this integral.
Are you recording right now? I hate you. I hate you. Okay, ready? But these are also rather different than the actual approximation, or the actual integral. How can we become more precise?
Well, they are rather different, but if we made the step size slightly smaller, we would get closer to approximating the actual integral.
I see. And why is the left-hand approximation less than the actual, while the right-hand is greater?
Well, it is in this case, but if, for example, we had a decreasing function, such as this one, then the left-hand approximation would be larger than the actual value of the integral, and the right-hand would be smaller, similar to the midpoint and trapezoidal, which would be switched.
I see. And if we wanted an exact approximation using summations, how could we do that?
Well, in order to do that, we'd have to take an infinite number of steps. So we'd have to make our step size very, very close to 0. But that's a lesson for tomorrow. So have a good day.
Dude, are you making like a documentary?